So today we look at one more method of solving quadratic equations. This one links back to Unit 2 quite nicely because this method involves nothing other than factoring. So the way that factoring works to solve quadratic equations, we need to have one side of the equation equaling a zero, and that is a very key point in this because of something called the zero product property, which basically says that if a times b equals zero, or another way of putting that, if two things multiplied together equal zero, then either a was zero or b was zero. The only way we can multiply two items together and get zero out as an answer is if one or the other one is zero. That is the key to what makes factoring work for solving quadratics. So we'll just jump straight into this. With a, we can see that we already have one side equaling zero, so we can just jump ahead straight into factoring that. Factoring it specifically, we need two numbers that will both multiply to 12 and also add to 8. Those numbers are 6 and 2, so that'll factor into x plus 6 and x plus 2. The only difference now is that we do have this in an equation. We do need to make it equal 0, so that does need to carry on down with it. The next piece is a little bit of new. Well, now we can say that we have two factors multiplied together. One of them is the x plus 6, the other one is the x plus 2. Now we can say, okay, we know that x plus 6 times x plus 2 equals 0. So we know that either x plus 6 had to equal 0 or x plus 2 had to equal 0. And that's that zero product property from the last slide. Once we get to this point, we have two basic equations that go back to grade 8, grade 9 level. On the left, subtract 6 from both sides to get x by itself. On the right, subtract 2 from both sides to get x by itself. And we end up with two solutions of x equals negative 6 and x equals negative 2. If this was the graph of this function, we would see that it would cross the x-axis both at negative 6 and negative 2. Moving on to question B, we have a 0 on one side, so that's perfectly fine. We then need to find two numbers that will multiply to negative 25 and also add to negative 10. This time it happens to be the same number twice. It's negative 5 and negative 5. So when we factor that out, we'll get x minus 5 and x minus 5 equals 0. Do not forget to equal 0 along with this because we do have the equation there. At this point, the method becomes exactly the same no matter what this factors into. We'll take that, we'll split it off. So we'll have the first x minus 5 equals 0 or the second x minus 5 equals 0. Now, at this point, because we have those factors being identical, we know that this is going to work out the same way both sides. We need to add 5 to both sides. So we don't actually need to write the answer down twice. This would just be x equals 5. And again, if this was a graph, this would be a parabola that would come down, touch the x-axis just at 5, and then it would be done. Moving on, same idea, c already equals 0. We need two numbers that will multiply to 8 and add to negative 6. Those would be negative 4 and negative 2. So we have x minus 4, x minus 2 equals 0. Do not forget the equals 0. I know it's a picky detail, but it is important. That was an equation to begin with. It needs to stay an equation. Once we get it factored, we can take it, we can split, so we have either x minus 4 equals 0 or x minus 2 equals 0. Taking each of those equations, solving them for x, adding 4 on the left, adding 2 on the right, we get x equals 4 or x equals 2. D might look a little different at first glance, but it is still factoring. This is just specifically a difference of squares. Hopefully that was easy enough to recognize. X squared minus 16 would factor into x plus 4 and x minus 4. Because it is an equation, it's x plus 4x minus 4 equals 0. Same method applies, split it apart, either x plus 4 equals 0 or x minus 4 equals 0. Getting x by itself on both of those, subtracting 4 on the left, adding 4 on the right, we get x equals negative 4 or x equals positive 4. Last two examples, these ones throw a bit of a hiccup into the process. In E, we do not equal 0. And that is a problem because in order for this method to work, in order for the zero product property to actually be able to take effect, we need to equal 0. So before I do any factoring, I am going to take that 21, subtract it from both sides, and get x squared plus 4x minus 21 equals 0. At this point now, I can factor this. Two numbers that will multiply to negative 21 and also add to 4. That would be 7 and negative 3. So when we factor this, we get x plus 7, x minus 3 equals 0. Method doesn't change, split it. Either x plus 7 equals 0 or x minus 3 equals 0. Get x by itself, subtract 7 on the left, add 3 on the right, and we get our two answers of x equals negative 7 or x equals 3. Last example, question F, same thing as E with that hiccup, it equals 35. We can't have it equaling anything other than 0, so we need to subtract 35 from both sides before we try to factor. X squared minus 2x minus 35 equals 0 is what we end up with at that point. Find the two numbers that factor, multiply to negative 35 and add to negative 7. Sorry, add to negative 2 would be negative 7 and 5. So the factoring is x minus 7, x plus 5 equals 0. Same as it was before, split this, either x minus 7 equals 0 or x plus 5 equals 0. Get the x by itself, add 7 on the left, subtract 5 on the right, and we get that x equals 7 or x equals negative 5.